Hi, good evening, everyone. So, up to now, we have been seeing the transient response of an RL circuit with unit step function. Let's try to do the same derivation with an unit ramp function. Already, we know that the standard ramp function is defined as R of S is equal to 1 by S square, and the standard current equation. So already we discussed the current equation. So by performing this, you can refer the previous video. So by performing KVL, we find the current I of S is equal to V of S into 1 by L divided by S plus R by L. So this is what the equation we have. Now from this equation, we want to find out I of T. So here I'm going to find out the current I of S is equal to. So what is the type of input we are applying here? So the input is nothing but R of S. We can write down this as 1 by S square into 1 by L divided by S plus R by L. So let's try to perform this calculation part. So 1 by L, so this is 1 by S square, this will come to the denominator and I do it as S square into S plus R by L. So that is equal to, so when you take the S square terms are there, when you take the partial fraction, you are going to get it as A by S plus B by S square plus C by S plus R by L. Okay. So when you see this equation, so the LCM for this you are going to get it as a S square into S plus R by L. So when you write down this, you are going to get A into S into S plus R by L. So this is the one equation you are going to get, plus B into, you are going to get S square will cancel, S plus R by L plus C into C into, so S by C into S square and S into R by L will get cancelled out. So this is how the equation you are going to get, and this is nothing but, so this denominator term will get cancelled. In order to find ABC, let us assume solve S is equal to 0. When S is equal to 0, automatically C will become as 0. Therefore, we are going to get, let us substitute S is equal to 0, then you are going to get 1 by L is equal to, when S term is 0, then you are going to get this term is also 0, and you are going to get B into S is equal to 0 as R by L. L is cancelled, therefore B is in numerator, so this can be written as B equal to 1 by R. And one more chance is there for finding the next term. Substitute S plus R by L equal to 0, therefore S is equal to minus R by L. Substitute in this equation, then you are going to get 1 by L is equal to, this term will become 0 and this term also will become 0. Then you are going to get C into minus R by L whole square, which is nothing but 1 by L C into R square divided by L square. L will get cancelled. Therefore, the value of C is equal to, this L will come to the numerator, which is nothing but L by R square. So the two possibilities are completed. Now let's try to multiply it. This is A S square, C S square. Compare the S square coefficients. When you compare this S square coefficients, this is A S square, you are going to have C S square. So when you compare these coefficients, the constant A plus C equal to 0, therefore A equal to minus C, and what is the value of C? Minus L by C square is the value of A. Now let's try to substitute in this equation, and the equation of I of S, we are going to get it as a I of s is equal to, what is the value of a, minus L by all square divided by s plus, what is the value of b, which is nothing but 1 by r divided by s square, plus what is the value of c, L by r square divided by s plus r by L. So this is how we have the equation of I of s. So but I require the current, which is nothing but the transient current in a series RLC circuit for an unit ramp function. So this is nothing but 1 by, I mean, inverse Laplace of so the inverse Laplace of 1 by s constant is 1, and inverse Laplace of 1 by s plus a is equal to e to the power minus 80. So this you can write down it as a minus L by r square, plus you can write down this 1 by r into, so Laplace transform of 1 by s square is t plus L by r square into e to the power minus 80, where the value of a is minus r by L into t. So where the I of t is called, so this I of t is called as the transient response of a series RL circuit with a unit ramp applied. So this is how to find out the transient response. If you want to revise, you can see the revision. So this is how to define a ramp. You can see in the previous video, 1 by s square. This I of s is divided as v of s into 1 by L into s by r as well. So when you write down this 1 by s square, then you are going to get a 3 partial fraction. Solve for ABC, then you are going to get ABC value. Substitute the value of ABC here, and this is in S domain, and we need to transform into time domain. I'm going to apply inverse Laplace transform, and you are going to get it. So this is how we have been applied. And next you can see here, similarly we want to find out the transient response of a series RL circuit for an unit impulse. Okay. So we need to find out the transient response of a series RL circuit with an unit impulse signal. So when you refer this standard video of an unit impulse signal, already we have been explained you what is meant by an unit impulse. So this is how the unit impulse signal is there, and the Laplace transform we are going to get it as 1. So we have the two functions here, and now let us try to find out the equation of I of s. So the current I of s is equal to the input, here it is delta of s. What is the delta? V of s is nothing but delta is nothing but input. Here it is 1 into 1 by L divided by s plus r by L. And here you can see here directly you can solve it. The I of s is in Laplace transform, and you can write down it as I of t equal to 1 into 1 by L. So L inverse, okay, inverse Laplace transform of 1 by s plus a equal to e to the power minus 80. So this is nothing but s plus a e to the power minus r by L into t. This is the expression of I of t, which is called the transient response of a series RL circuit with which type of input? Unit impulse function. Hope today you have been understood about what are different standard test signal, unit step, unit ramp, unit parabola. and how to find out the transient response, which is nothing but the expression of I of t for these three inputs. Hope the video is very useful to you, and if you feel it is useful to you, please give a valuable like, share to your friends, and subscribe to the channel for the more updates. Yeah? So by giving a support with like, share and subscribe, you can invest more time and we can give you the more videos, which will be like a small encouragement from your end. Thank you for your help and support. Thank you. So yours obediently, Ram.